Imagine closing your eyes for the last time, not in death, but in transformation. Your consciousness lifts away from flesh and bone, expanding into a vast digital realm where thoughts travel at light speed and memories never fade. You can access humanity's entire knowledge base in milliseconds, share emotions directly with loved ones across the globe, and exist simultaneously in countless virtual worlds. Death has become as obsolete as the telegraph. But here is the question that will haunt us for the next 20 minutes. If you could live forever as pure consciousness, would you still be you? This isn't science fiction anymore. Right now, in laboratories around the world, scientists are developing technologies that could fundamentally redefine what it means to be human. We're reapproaching the most profound transformation our species has ever faced, the moment when consciousness breaks free from biological constraints entirely. Today, we're diving deep into 3 revolutionary possibilities that could reshape human existence within your lifetime. We'll explore how brain-computer interfaces might allow minds to merge and communicate directly. We'll examine the tantalizing prospect of digital immortality, where consciousness could be preserved and enhanced beyond biological death. And we'll grapple with the mind-bending ethical questions these technologies raise about identity, free will, and what it truly means to be alive. By the end of this journey, you'll never think about consciousness, mortality, or human nature in quite the same way again. So buckle in, because we're about to explore the most transformative possibilities our species has ever contemplated. What is consciousness? Before we can understand where consciousness is heading, we need to grasp what it actually is, and that's surprisingly more complex than you might think. Right now, as you're processing these words, billions of neurons in your brain are firing in intricate patterns, somehow creating your subjective experience of being you. But how does electrical activity in neural tissue give rise to the rich inner world of consciousness? Scientists call this the hard problem of consciousness. We can measure brain waves, map neural networks, and even predict some thoughts with remarkable accuracy. But we still can't explain why there's something it's like to be you, why you have an inner experience at all, rather than just being a biological computer processing information without any subjective awareness. Consciousness isn't just one thing. It's layered in ways that become crucial when we start talking about digital minds. There's basic awareness, which even simple organisms possess, the ability to respond to your environment. Then there's self-awareness, recognizing that you exist as a distinct entity separate from everything else. Beyond that lies metacognition, the ability to think about thinking, to be aware of your own mental processes. Intelligence is something entirely different. You can have incredibly sophisticated information processing without consciousness, just as you can have consciousness without exceptional intelligence. This distinction becomes vital when we consider artificial minds that might match human intelligence while potentially lacking subjective experience. Current neuroscience tells us that consciousness emerges from approximately 86 billion neurons, each connected to thousands of others through networks that make the internet look simple. These create what researchers call neural correlates of consciousness-specific brain activity patterns that correspond to conscious experiences. But here's what makes this mystery so urgent. We're about to start manipulating consciousness in ways that would have been unimaginable just decades ago. Companies are developing technologies that could enhance, merge, or even transfer consciousness entirely. And that brings us to our first revolutionary possibility. Merging minds with technology, the future of consciousness isn't arriving gradually. It's being built right now, one neural connection at a time. Elon Musk's Neuralink has already demonstrated monkeys playing video games using only their thoughts, controlling computer cursors through implanted neural chips with remarkable precision. But this is just the beginning. These brain-computer interfaces, or BC, work by detecting the electrical signals your neurons produce when you intend to move or think specific thoughts. Current systems help paralyzed patients control robotic arms or computer interfaces through thought alone. But next-generation BC will be far more sophisticated, capable of reading and writing complex patterns of neural activity associated with memories, emotions, and abstract thoughts. Imagine augmenting your memory not with external devices, but with direct neural interfaces that expand your brain's storage capacity infinitely. You could download new skills overnight, access vast databases of knowledge instantaneously, and never forget another important detail. The boundary between your biological memory and digital storage would blur until it disappears entirely. But here's where things get really mind-bending. When two people have compatible neural interfaces, they could potentially share thoughts and emotions directly, without language or any external communication medium. This isn't just improved texting. It's technological telepathy that could transform human relationships in profound ways. Picture a world where miscommunication becomes obsolete, where you can truly understand another person's perspective not through empathy and imagination, but through direct access to their neural patterns. Emotional intimacy could reach unprecedented depths when you can literally feel what someone else feels, think what they think, experience what they experience. The implications for human collaboration are staggering. Research teams could merge their consciousness temporarily, creating collective minds that combine individual expertise and creativity in ways impossible for separate brains. Complex problems that take individual researchers years to solve might be resolved in hours by temporarily merged consciousness. But this technological telepathy comes with risks that are as profound as the benefits. When minds can connect directly, the privacy of your inner mental life, perhaps the last truly private space in human experience, could be compromised. Hackers could potentially access your thoughts, manipulate your memories, or alter your personality through neural interfaces. There's also the question of mental authenticity. If your memories can be enhanced or modified through neural technology, how do you know which thoughts are genuinely yours? When your mind becomes networked with external systems and other people, what happens to your individual identity? Companies like Synchron, Kernel, and Paradromics are racing to solve these challenges, developing higher bandwidth neural interfaces that could read millions of neurons simultaneously. The technical hurdles are enormous. Mapping even a fraction of your brain's connections requires unprecedented precision. But progress is accelerating rapidly. Yet merging minds through technology raises an even deeper question. If consciousness can be shared and networked, could it also be copied, transferred, or preserved beyond biological death? That brings us to perhaps the most audacious goal in human history. Digital immortality. Death has been humanity's ultimate constraint. the final boundary that gives urgency to our choices and meaning to our mortality. But what if death became optional? What if consciousness could be freed from biological brains entirely, uploaded to digital systems that could preserve and potentially immortalize the human mind? This is the promise of digital immortality, the theoretical ability to scan, map, and recreate human consciousness in a computer. Your brain contains roughly 86 billion neurons, each connected to thousands of others through pathways that encode your memories, personality, skills, and everything that makes you uniquely you. In theory, if we could map every neuron and connection, we could recreate that same structure digitally. A complete brain map would require measuring trillions of synaptic connections with precision beyond current scanning technology. Even if we captured such detailed information, we'd need computers with processing power far beyond today's capabilities. More fundamentally, we still don't fully understand how consciousness emerges from neural activity. Consciousness might depend on quantum effects in brain cells, on precise biochemical environments, or on aspects of brain function that can't be captured by digital simulation. We might be trying to digitize something that's inherently biological, but let's assume that technical problems can be solved. This leads to the most mind-bending philosophical question. Would an uploaded consciousness actually be you, or would it be a copy that thinks it's you? If your biological brain dies during the upload process, you might experience continuous consciousness transferring to digital form. But from an outside perspective, your original self died, and the digital entity is a separate being with your memories and personality. Consider this thought experiment. What if we could upload your consciousness gradually, replacing biological neurons with digital equivalents one at a time over months? At what point would you cease to be biological and become digital? Would your consciousness remain continuous throughout, or would you gradually die as your digital copy comes alive? The implications of successful mind uploading extend far beyond individual survival. Digital minds could exist in virtual worlds, limited only by imagination and processing power. They could experience time at different rates, living centuries of subjective experience in minutes, or slowing down to contemplate problems for subjective millennia. They could back up their consciousness, create multiple copies, or revert to earlier versions. Digital consciousness could also enhance itself in ways impossible for biological brains. Uploaded minds might expand their memory infinitely, increase processing speed dramatically, or modify their personalities and abilities at will. The digital version might become so enhanced that it bears little resemblance to the original human. Current research is making progress toward this goal. Scientists are developing detailed maps of neural connectivity in simpler organisms. Computer models of brain function are becoming increasingly sophisticated. The storage and processing power needed for brain simulation grows exponentially each year. Yet many experts believe digital immortality remains decades or centuries away, if it's possible at all. Consciousness might be irreducibly tied to biological processes that can't be replicated in computers. But the mere possibility is already changing how we think about death, identity, and human nature. Which brings us to perhaps the most important question. Even if we can merge minds and achieve digital immortality, should we? Ethical and societal implications we're not just developing, New technologies, we're rewriting the fundamental rules of human existence. The possibilities we've explored force us to confront basic questions about identity, mortality, and what it means to be human that philosophers had debated for millennia. Let's start with identity. What makes you you? Is it your memories, your personality, your continuous stream of consciousness? Current legal systems assume each person has a single, continuous identity tied to a biological body. But what happens when consciousness can be copied, merged, or transferred? If you upload your mind and your body dies, which entity inherits your property, relationships, and legal identity? Religious communities face equally profound challenges. Most spiritual traditions assume consciousness connects to a soul that transcends the physical brain. How would these beliefs adapt to technologies that treat consciousness as patterns of information that can be copied and manipulated? Would an uploaded mind have a soul? Could merged consciousnesses share spiritual essence? The concept of free will become murky when consciousness can be technologically manipulated. If your thoughts can be influenced through neural interfaces, if your memories can be modified, if your personality can be adjusted digitally, are your choices really your own? Moral responsibility assumes individuals have agency over their actions, but consciousness technologies could blur the line between genuine choice and technological influence. Consider the potential for unprecedented inequality. These technologies will likely be expensive initially, accessible only to the wealthy. This could create not just economic disparity, but cognitive and existential inequality, permanent divisions between enhanced and unenhanced humans, between the digitally immortal and biologically mortal. Current social inequalities could seem trivial by comparison. There's also the risk of technological dependence. If our memories, emotions, and thoughts become dependent on digital systems, what happens when those systems fail or fall under others' control? We could become vulnerable to manipulation and coercion impossible with purely biological consciousness. Privacy takes on entirely new dimensions when thoughts become accessible through technology. The most intimate aspects of human experience, our internal monologue, private fantasies, embarrassing memories, could become visible to others or subject to external control. Mental privacy, which we currently take for granted, might become obsolete. Yet these technologies also offer unprecedented opportunities for human flourishing. Neural interfaces could eliminate mental illness and cognitive limitations. Merged consciousness could foster empathy and cooperation on scales never before possible. Digital immortality could free us from death's fear and allow unlimited time for growth and discovery. The key question isn't whether we should pursue these technologies. The potential benefits are too great to ignore, but how we develop them responsibly. We need new ethical frameworks, legal systems, and social institutions designed for an age of technological consciousness. This requires global cooperation on unprecedented scales. Consciousness technologies are too important and dangerous for individual companies or countries to develop without oversight. We need international standards for neural privacy, rights for digital minds, and protections against technological manipulation. Perhaps most importantly, we must preserve meaningful choice. Not everyone will want enhanced consciousness, merged minds, or digital immortality. The future should include room for traditional human consciousness alongside technological alternatives. Closing in call to reflection, we began by imagining consciousness breaking free from biological constraints, and we've explored the cutting-edge science making this possible. We've seen how brain-computer interfaces could allow direct mind-to-mind communication, how consciousness might be preserved digitally beyond death, and how these possibilities raise profound questions about identity, free will, and human nature. What strikes me most is how little we understand about consciousness itself, even as we prepare to fundamentally alter it. We're developing technologies that could merge minds before fully understanding individual consciousness. We're pursuing digital immortality while debating whether uploaded minds would truly be conscious at all. This uncertainty doesn't mean we should abandon these pursuits. The potential to eliminate death, enhance human capabilities, and foster unprecedented empathy and cooperation is too valuable to ignore. But it does mean we need appropriate humility and caution as we proceed. The future of consciousness will likely be stranger than anything we've discussed today. Real developments will emerge gradually, with unexpected capabilities and consequences we can't anticipate. The interaction between human creativity and technological possibility will create realities more complex than our current speculation. What seems certain is that consciousness as we know it, private, individual, bounded by biology, terminated by death, represents just one chapter in a much larger story. We're living through the moment when our species gains power to redefine mind, identity, and existence itself. The questions we've explored don't have simple answers, and new questions will emerge as these technologies develop. But that's what makes this historical moment so extraordinary. We're not passive observers of change, we're active participants in shaping consciousness's future. The choices we make about research priorities, ethical standards, and social policies will determine whether these technologies enhance human flourishing or create new forms of suffering. Your voice in these conversations matters because the future of consciousness isn't something that will happen to us. It is something we all will create together. So here's my final question, and I genuinely want to know what you think. When our minds can live anywhere, merge with others, and persist beyond biological death, when the very boundaries of self become fluid and optional, will we gain everything or lose ourselves entirely? Let me know in the comments, because this conversation about humanity's future is just beginning, and your perspective could help shape how it unfolds.